Hi, welcome to the MSC channel. In this clip, we introduce the impact Charpy test. In the past, this test was performed by non-automatic devices. But today, automatic devices have also been created for the Charpy test. Charpy test samples are created according to ISO 148-1. The width and thickness of these samples are 10 mm and their length is 55 mm. The middle of the sample is V-shaped, with a radius of 45 degrees, or with the end of the semicircle. The hammer hit the sample exactly from the back of the gap. In this figure, you will see a schematic of the Charpy test machine. Charpy test device weighs between 300 and 700 kilograms based on the model. Existing devices are capable of measuring impact energy of up to 800 joules. This device works according to energy law. This way the hammer with 150 degrees of the sample is abandoned and hit the sample at 0 point. At this point, due to the weight of the hammer, its speed will be between 5 and 5.5 meters per second. If the sample absorbs all the kinetic energy of the hammer stops in the collision. Otherwise, the sample absorbs some of the energy and the hammer with the residual energy moves up. In this section, we perform the test. Our examples were made from screws. These samples were created according to the ASTM F606M standard. ISO 898-1 is related to the mechanical properties of the screws. According to this standard, the impact test should be performed at a negative temperature of 20 degrees. If the energy absorbed during the impact test is 27 joules and more, the screw has a good impact. We use dry ice to reduce temperatures to a negative 20 degrees Celsius. The dry ice temperature is negative at 78.5 degrees Celsius. It should be noted that dry ice should not be contacted directly with the body. The samples should be placed in dry ice with a container for 30 minutes. After 30 minutes, measure the temperature of the samples. The hammer must be attached to the latch. Then raise it to 150 degrees. To do the test, release the latch. In this device, the energy is measured from 1 to 30, which means 10 to 300 joules. Thanks to Dr. Jafarian and engineer Partoyer, from the Iran University of Science and Technology.